Today, I will demonstrate the automatic analysis of core dump files for OpenResty or Nginx applications. Run the ls command to list all files under the current directory. We can see a new core dump file here. While core files can be stored in various directories, our application is pre-configured to save them here for convenience. Run the redlink command to view the absolute path of the file. Let's use OpenResty X-Ray to perform a real-time analysis of this core file to find out the cause of the process crash and the context information. Copy the path of this core file. Open the OpenResty X-Ray web console in the web browser. Make sure it is the right machine you are watching. You can choose the right machine from the list below if the current one is not correct. Go to the guided analysis page. Here, you can see different types of problems that you can diagnose. Let's select core dumps or process crashes. Click on Next. Paste the path of the core file we just copied here. OpenResty X-Ray automatically extracts the executable file path from this core dump file and fills in this text box. Make sure that the application type is correct. Usually, the default should be correct. Let's start analyzing. The system is executing the analysis. The analysis is done and it is generating a report. We can see it automatically created an analysis report. In the top right of the report, you can see the path of the core file and when it was created. Let's check the execution context first. Check the machine code level information. It is these EGV signal that triggered the core dump. Below are the detailed explanations of this signal. SEGV stands for segmentation violation and usually indicates an illegal memory access that has occurred. In this section, you will find the disassembly code around the currently executing instruction. A red arrow in front indicates the instruction currently being executed. A segmentation fault occurred while this instruction was running. The instruction is currently accessing a specific memory address. This is the value of the CPU register when the core dump occurred. This is the current C backtrace being executed. This is a function from the GNUC library. It copies a block of memory from one location to another. This function is a part of Lua-JIT. It handles the _index meta method for FFI data types. NGX HTTP Lua run thread is a function from the Nginx web server that runs a Lua routine. NGX HTTP core content phase is responsible for processing the content phase of the HTTP request processing cycle. This is the Lua backtrace being executed. This C function performs the memory copy operation, which we already saw in the C backtrace. These two meta methods are called when accessing a field member inside data. Decode order data is a Lua function in the business code. Click more to see more details. The backtrace above is automatically inferred from this Lua CPU flame graph. Below is the full call stack trace, containing the values of all parameters and local variables in each Lua function frame. Click here to view all the local variables and parameter variables of the function decode order data. Let's go back to the business level function decode order data. Hover the mouse over the green box for this function. We can see the source file of this function and its full path in the tooltip. The source line number is 79. Click the icon to copy the full source file path for this function. Use the Vim editor to open the source file and look at the Lua code in this file. You can use any editors you like. Go to line 79, as shown in the report tooltip. The program tried to access the user id field of order data. Maybe this order data is null. This caused a segmentation fault, and the program crashed. So, there should be a check to see if order data is null before accessing it. This line is in the function decode order data, as shown in the report. This is the most common Lua backtrace among all existing Lua coroutines. The sleep function in C is used to pause the execution of the current thread for a specified number of seconds. This shows the information of all HTTP requests running when the core dump occurred. This is the information on the HTTP request that the Nginx process handled when the crash occurred. This displays the IP address of the client that initiated the request. The request method is POST. This is the URI of the request. We can check out all the other concurrent HTTP requests being processed. The report also contains memory analysis. This is the #1 hottest data reference path for Lua GC object memory distribution. This path is essentially saying, go to the registry table. Find the _loaded table. Within that, find the engines.sray.sray lib module. Access the run rules function or data. This path was automatically derived from this Lua GC object memory distribution flame graph. OpenResty X-Ray can also monitor any new core dumps generated from online applications. It can also automatically analyze the files and generate automatic analysis reports. Go to the Insights page. You can find the automatic reports on the Insights page for daily and weekly periods. For this reason, you don't have to use the guided analysis feature. Guided analysis is useful for application development and demonstration purposes. OpenResty X-Ray is a non-invasive diagnostic system based on our own dynamic tracing technology. It can monitor and scan various kinds of problems in real time. For example, performance bottlenecks, stability issues, errors and exceptions, as well as security vulnerabilities. If you like this video, please follow us on YouTube. Thank you.